For those of us that have been following this journey of the investigation of aluminum, you would be thinking to yourself, how do we even find ourselves here? How is this even a controversy anymore? It is so clear that scientists around the world are doing independent studies and piecing together this incredible discussion about the possibility that autism and other autoimmune diseases are being caused by aluminum, and specifically the aluminum adjuvant in vaccines. But really, I think we've talked about it before. One of the biggest studies to come out that sort of brought this whole thing full circle was the dissection of 5 autistic brains by Professor Christopher Exley. And it is my true honor and privilege to have you with us here today.
Good to be here.
Really thank you for joining us. First of all, you are one of the sort of chairs of the event that was taking place yesterday, the focus on the 5th annual vaccine conference, you and Roman Girardi. How did you think it went?
I thought it went very, very well. I thought we had the right mix of contributors. We started off in the morning primarily looking with clinicians and looking at what happens there in the clinic, what people are seeing. And then we moved in the afternoon, perhaps to some of the more harder science, where we are actually trying to understand what may be going wrong. So I thought it went very well. I like the fact that we encouraged discussion. So people like yourself were asking questions, which was good. And that's what we need. It doesn't matter who asks the questions. It's the important things that questions are asked. And there is an opportunity to air those and, of course, for the answers to be aired. Because often when you're talking at a meeting, you stick to a relatively rigid format. It's only when you're able to move outside of that and perhaps move into areas that you might be more speculating about or something of that sort. So I thought that went really well.
What is the deal with the fact that, I mean, here these scientists are stepping out there. We know this isn't anyone, but there was literally doctors that were putting up pictures of their children and their photo of their vaccine record at the end of their, their
Absolutely.
talk. Why are they doing that?
Is this when they did it? I think it, the audience seemed to appreciate it in some ways. I didn't appreciate it. I find that a sad indictment of where we are today. I have never apologized for my science, and I will never apologize for it. And that really is what this was about. It was as if to say, the science I'm doing does not mean this, that, or the other. Science has always spoken for itself. This is the most important thing that we should try to take away from this. When the science is robust, rigorous, reproduced, published, then it stands alone. And you should not have to make the point, for example, oh, you see, I am not anti-vax or anything of that sort. Why would you have to make that point? You probably know already that someone like me, who literally does not work on vaccines. I do not work on vaccines. But you Google my name and now I'm an anti-vaxxer. I don't even work on vaccines. But of course, my research, which is on aluminium, that's our expertise. And of course, aluminium is used in vaccines. Our research puts us in a position whereby we implicate the aluminium in a vaccine in one of the serious adverse events, which we know happen sometimes following vaccination.
Right.
But that is not something that I am apologizing about, because my raison d'etre in science, and there is only one actually, is to understand aluminium in living things.
That's been your complete and total focus.
And if I was prevented from doing that, which is not impossible that could happen simply through a lack of funding, I would stop science. I am not going to change my subject. I've had the privilege of working with great scientists throughout my life. And many of them have always given me the very best advice. And that advice was usually do something else, because don't work on aluminium. That was pre-vaccine.
Really?
Because even then, working on aluminium, they saw it as a really difficult thing to do, difficult to get funding, difficult to get any sort of consensus. And so the advice was, don't do it. But of course, when someone tells you not to do something, you always do it, don't you? Remember as a child, you're told not to do something, you do it.
I suppose that's true, especially if I think that you have a certain type of spirit that clearly you like a challenge. What got you into aluminum? Why aluminum? I mean, I was just saying, we talked a little earlier today, but afterwards I was saying to some of the people on my team that it's really amazing that someone like yourself, I mean, you have focused almost 3 decades now?
35 years.
On aluminum. 35 years on aluminum alone. And how fascinating is that it's come into this place where, I mean, it was always important, but it may be one of the central points of this vaccine issue now. I mean, you sort of accidentally find yourself in the middle of, I think, one of the biggest what would you say? When we look at the problems with vaccines, aluminum really, from so many different vantage points beyond your own, is really in the crosshairs now of one of the problems.
Let me tell you a small story.
Okay.
Something which happened to me in the early days of my scientific life, when I was looking at why fish were killed by aluminium, why aluminium was toxic in fish. And I had to set up experimental systems, experimental tanks, where I exposed, and these were small salmon to the amounts of aluminium, actually the same amount that is allowed by regulations and things like drinking water, so not large amounts. But this amount of aluminium was almost immediately toxic to salmon. And I used to, as part of my research, I had to observe what happened. So for example, one of the things that I always remember, one of the great observations for me was in the early stages of toxicity, as soon as the fish were perceiving the presence of the aluminium, they started to do unusual things, at least at the time for me, I thought they were unusual. What they would do was orientate towards surfaces or corners. Now, does that ring any bells anywhere? In other words, they were looking for hiding places, even though none were there within the tank system. But they were looking to put themselves in a corner, at the side.
So behavioral, like a behavioral change.
And of course, 35 years later, we've done the first research on aluminium and autism. And what are some of the characteristics of an autistic child? I'm not saying that those salmon were suffering from autism, but what I'm saying is that what I could learn then from understanding the way aluminium interacts with a fish is no different in terms of the detailed biology and biochemistry than what we can learn today and what we have learned since in the way that aluminium interacts in human beings. And a human is a bit bigger than a small salmon.
Absolutely.
So the exposure system is different, completely different. But the way in which the aluminium may interact can be very, very similar. So that brought me into the subject. It also made me feel sad for the fish. I really don't enjoy seeing anything suffering. And I've done very little animal work ever since. And indeed, in the last 5 or 10 years, we've more or less only worked on humans, hopefully not making them suffer.
But you started, fish was your focus. I mean,
absolutely.
You were into fish. What was the crossover point? When did you move from fish into looking into humans?
When we started that work, and that was in the late 80s, early 90s, and that was a time when you were allowed to work on aluminium. There was an interest in aluminium. At a meeting like this, there really would be a whole symposium simply on aluminium, not in relation to autoimmunity or something, but the subject of aluminium would stand alone. And of course, that doesn't exist now for all sorts of different reasons.
Well, because you say we're in the aluminum age. I mean, that's one of the things you say. The world we now live in is so much based on aluminum, right?
Yeah, I mean, every single thing that we do means that we are exposed to aluminium in our everyday life in every single way, to the extent that I always say that in every individual, in every cell in your body, you've got at least one aluminium atom. Now, what we were able to learn in those early days working on fish And I had no particular interest in fish or saving fish. The fish was a model for me to understand aluminium. What I was able to learn there is exactly what I can take that information. And I started being asked questions about, what about aluminium and Alzheimer's? Because in the early 90s, it's a big controversial subject. So we moved into that area. And we started to perhaps do some of the seminal work in that area, and we continue to do so up until today. And of course, in many ways, that's what happened with autism. I had absolutely no interest, per se, with respect to aluminium and autism. And indeed, I really did not believe there was any mechanism whereby aluminium and exposure in infants could be involved in autism. But we kept being asked the question. And I kept seeing what I thought was relatively poor research published in that area, making correlations, speculations in this area. So it needed something to be done. We needed to go as hard as possible at that. And our idea of going as hard as possible was simply to say, well, look, in Alzheimer's disease, we've already shown that aluminium is almost certainly a contributor to Alzheimer's. And the way we did that was by looking at many Alzheimer's disease brains.
How many did you look at? How did that process go? Because I remember that. I remember this discussion going on. I'm sure some of it must have been being driven by the work you were doing, but I was just aware that there was a discussion of aluminum, deodorants, things like that, maybe leading to Alzheimer's. So when you looked at it, what was the process?
Well, again, serendipity plays a huge part in science, particularly when you're working in an area of science that no one wants to support or fund. And what happened was somebody died in an area of England, and their death was tentatively related to a pollution event 20 years earlier. And in that pollution event, lots and lots of aluminium sulfate, which is used to clean our tap water, both in the US and in the UK, had been inadvertently put into the water supply. So many people in a particular town had been exposed to it. One of the people in that town who had been exposed 20 years later, but in their early 50s, developed a rare form of Alzheimer's disease, and a rare form of Alzheimer's disease with absolutely no genetic predisposition. So it was completely environmental in some form. And we had an opportunity through them to look at the brain tissue of this individual, and using the methods that we had then at the time, we found the alarming result of very, very high levels of aluminium in the brain tissue of that individual. And in some ways, we were not the first people to measure aluminium in human brain tissue. We were certainly the first in this particular type of Alzheimer's under these particular conditions. And I would modestly say we might have been one of the first to do the job properly. Now that data evidence had to go to a coroner's court, and discussions with the coroner went down the line, we don't have enough information. What do we need to do? So I said to the coroner, well, if you can get me funding, we need to look at as many brains as possible. And that's exactly what the coroner did. The coroner funded us to look at 60 human brains, and we did our seminal 60 human brain study, which was published in 2012. And that began, for us at least, the proverbial road to Damascus. That was where everything went from being, well, maybe or maybe not aluminium was involved in Alzheimer's, to where we are now, which is aluminium is definitely, under certain circumstances, involved in Alzheimer's. So again, it's like a serendipity. The funding came from a coroner who needed more information to go to a coroner's court about the death of a woman who died with large amounts of aluminium in her brain.
When you said that you were maybe the first ones to do it right, as far as analyzing these brains, what did you do differently, and how is it looked at now by the industry?
Yeah, I mean, one of the ways in which any research on aluminium in humans, and human brain tissue in particular, has been refuted is because aluminium is ubiquitous. Aluminium is everywhere. So how do you account for the fact that it just get there by chance? The aluminium in the brain tissue was just got there in the process of collecting the brains and doing the analysis. Now we had to take account of that, because actually there's an element of truth in that. If you don't do things properly under the right sets of conditions with the right sets of controls, we love the controls now, don't we?
Yeah.
Then it could be that any data you produce is simply due to contamination. And this was a really strong argument for the aluminium industry and others, that everything that everybody was measuring was just reflecting the fact that the environment is full of aluminium. So we did some of the most rigorous controls that have ever been done. And very, very briefly, because you don't want to hear about all of this, we essentially, my researcher would go to the brain bank. There somebody would show them the particular one of the 60 different brains. They would then cut with a Teflon knife a part of the brain. It would then go into a completely clean, pristine container. Actually, for every time we did that, we took a container and put nothing in it. So we had a control.
A control container?
Exactly. A control for the process of being in that room at that time, doing that cutting.
Wow.
And now every stage from that onwards, from bringing that back to our lab and every other stage that's necessary to bring it to the point where we can actually do the measurement, there is a control. We call it a method blank. And we performed about 150 in total method blanks, which we could then determine, right, how much aluminium, if you do everything that you would have to do in the normal measurement process, how much aluminium could get into that simply by chance? And we measured that, and then we decided to multiply it by 3 the amount, so that we made it as rigorous and robust as possible, which meant actually that sometimes our control was higher than the amount we measured in some tissues, but we wanted it to be so robust. And that method is now published. It's a seminal piece of work, and we only use that method now. So every time we measure aluminium in human tissue, not just brain tissue, that is the method that we use.
Wow.
And that ensures I know that no one ever sits like you are next to me now and tells me there's anything wrong with my data, because they know there isn't. And that makes a difference. So what that means is that when we measure aluminium in human brain tissue, it doesn't matter if we get a low value or a high value, it's the real value. That aluminium was in that brain tissue.
So we won't get too much deeper into Alzheimer's, except that obviously you came to a very strong conclusion that there was a strong connection between aluminum and
well, I came to the conclusion that no aluminium, no Alzheimer's.
No aluminum, no Alzheimer's.
In the brain.
Wow. So then you decide to look at autism. You said that you were skeptical, that you didn't see that.
As a scientist, you clearly read the literature, stuff that other people produce. There were a number of papers making the suggestions. I wasn't convinced neither by the quality of the papers and the research, but even then I have to think, so what is the mechanism? That's what I learned as working on fish. What is the mechanism? You must have a mechanism as well as just something being there.
Right.
And I couldn't think of the mechanism. But by going to the brain tissue, it would at least give us an opportunity to make the first major step. Either we find no aluminium beyond the method blank type value in the brain tissue of people with a diagnosis of autism, or we find some aluminium, or we find a lot of aluminium.
What did you find?
We found a lot of aluminium. We found a scary amount of aluminium. So in individuals ranging from an age of, these were from 15 to 50 years of age, again, we measured some of the highest values of brain aluminium ever measured by our group, or indeed by any other group using other methods.
This saying a lot, since your focus has been aluminum your whole life, that you're saying it's some of the highest levels you've seen.
That in itself obviously set off alarm bells. We were pretty scared, actually. When you start to find something like that, it does set off alarm bells and red flags. And obviously you repeat things, you do it again, you've got additional samples you can use, you do them again, you check. But we're finding the same thing. So we know that these data are good, we've done it now, we know our stuff. But we also had an opportunity that was just with 5 frozen brains. And by the way, people say it's only 5 brains. There were only 5 brains available in the United Kingdom of people who died with an autism spectrum disorder who had donated their tissues. You know, the brain banks are not overloaded with tissues. And don't, by the way, anybody thinking about doing that, please do, but wait till you die, of course. So there were only 5 available for quantitative analysis, but there were tissues from 10 individuals in the brain bank that had been fixed. That means prepared for microscopy. These could not be used for quantitative analysis, but we did the microscopy on them. And the other thing that we've done in the last few years is designed a beautiful method, a simple method for looking for aluminium in human brain tissue. It works beautifully, and again, we have it totally validated. So we know that if we get, it works out as a fluorescent image, a fluorescent orange color, 100% that is aluminium. Now, when we looked in the autism tissues, in 10 of them, not 5, all 10, we've made an acid. In all of our work previously, particularly in Alzheimer's disease and in healthy but dead, if that's possible, brains and other conditions, when we find aluminium, we nearly always find it associated with damaged tissue, dead neurons, sometimes inside living neurons which are about to die. But we call it mainly extracellular deposits. When we looked in the autism brains, we found almost the complete opposite. 90% of the aluminium that we were finding by fluorescence microscopy was inside cells, not on the outside. So inside the brain tissue, but inside cells. Not only that, it was not inside neurons. It was inside these cells known as the glia. These are the housekeeping cells of the brain. These are the cells that ensure that the brain works properly. In an infant, they ensure that the brain develops properly. So these are critically important cells that nourish and nurture the neurons that everyone knows about, the nerve cells. And they were full of aluminium. And any cell that's full of aluminium is not doing its job properly. Add to that, so some of these cells, they could have picked up their aluminium from inside the brain itself, because that's where they reside. But identical cells to those are known to pass from the body into the brain under certain circumstances across the blood-brain barrier. And we even found some beautiful images of these cells crossing the blood-brain barrier, crossing another area of the brain, which we know called the meninges. So evidence that cells could come from outside the body, outside of the brain and up into the brain. These cells were also loaded with aluminium. Why did this, become an epiphany for me in terms of aluminium and autism? Well, simply because up to that point, we have been researching what happens at the injection site of a vaccine. And one of the things we've found is we've been looking at the types of cells that go into the injection site of a vaccine, and we've been looking at how they load up with the aluminium adjuvant in the vaccine. They fill their cell body with aluminium adjuvant, and they remain viable. And this is some of the new research we showed this time at the meeting. They remain viable for at least 24 hours and probably longer. These are known as immunoreactive cells. They're the same cells that can go across the blood-brain barrier and into the brain. In other words, a cell that picks up aluminium at the injection site of a vaccine can go and deposit its aluminium in brain tissue.
What was it about your study that led you to think that it could be a vaccine? I mean, certainly people say, you've already said that there was aluminum in the environment, that that's what's causing Alzheimer's.
Yep.
So why would it just be environmental aluminum we're eating causing autism or affecting these brains?
First of all, what we've shown, again, you mentioned it yourself in your preamble about what scientists say, and you're absolutely right. What we have shown is that there's a lot of aluminium in brain tissue taken from people who've died with an autism spectrum disorder, and we've shown what the distribution of that aluminium is. We have not shown where the aluminium comes from, but it's a valid question because We know the aluminium is in these pro-inflammatory cells. We know those are the same cells that populate the injection site of a vaccine with an aluminium adjuvant. And we have not come across any other circumstance, under any other set of conditions, in any other tissue where we have seen the same thing. In other words, if similar cells were loading up with aluminium in the area of the gut or in the liver or the heart or somewhere, but loading up from aluminium that wasn't coming from an adjuvant, from a vaccine, we should have come across it by now. Now, why haven't we come across these same cells full of aluminium in Alzheimer's disease brains? Why not? There's no reason why not. And possibly there is a reason why not. And the reason why not is that the way aluminium gets into the brain in Alzheimer's disease is generally a slow but sure accumulation, usually over decades. Here we have something where a really significant amount of aluminium could enter the brain in days or weeks following, for example, an exposure like a vaccine. So we don't have, we don't have the exact evidence that the aluminium that we saw in these brain tissues came from a vaccine, but we have plenty of evidence to say that we've never seen evidence of it having come from anywhere else. So you have to put together the different types. And one thing we have got better than anybody else around the world is evidence of aluminium in human brain tissue. This is something that we are now, paramount in what we do. We're right at the top of that and its understanding. So we can make those comparisons. A really valid criticism of our autism study was you had no control tissues. How do we know that that's not a normal situation? Well, first of all, we know it's not a normal situation because we have measured more than 100 other human brains, never seen the same thing.
Right.
In all sorts of other conditions. So we are allowed to make that comparison, I think.
Right.
The other thing is that we were provided with 5 control brains to look at. But the average age of these individuals was about 50. And they all died of some really quite horrendous disease, Alzheimer's, suicide. In other words, they all had associated brain pathology anyway. So we couldn't, they were not a control. They were a bit like the vaccine industry's control.
Sure, right, yeah, it's an already damaged control. Well,
Yes.
look, when you do work like you're doing, there's a lot of pushback, and it's not being well received. In fact, that's the need, I think, for this conference. And the scientist that's putting on this conference right now, Yehuda Schoenfeld, is really behind this autoimmunity conference, and then allowing for this specific day looking at vaccines and adjuvants. I had the opportunity to sit down with Yehuda to just talk about generally the work that he's doing, why this is an important conference. Take a look, it's very interesting.
This conference is part of my interest to spread knowledge on autoimmune diseases. This is the 11th one and the biggest one with over 2,000 participants, in which all aspects of autoimmunity, factors, therapies, mechanisms, associated disease are discussed by these 2,000 participants. All the leaders in the field are here to discuss it, to exchange knowledge, to start new research, etc. We have 80, maybe even 81 or 82 different autoimmune diseases. So my role was that I would like to see the knowledge spread all over the world, to find better therapies for autoimmune disease, and also to find the factors to see how we can prevent autoimmune diseases.
Is autoimmune disease on the rise, or do you think it's steady throughout time?
No, definitely it is at a rise, and actually it even rises exponentially during the last years. And the reasons are the environmental factors. It's not that everybody is at a risk to develop autoimmune. There are genetic components which makes you to be at a higher risk.
Tell me about Asia, autoimmune syndromes induced by adjuvants.
Asia, it means one of the 80 autoimmune diseases induced by adjuvants. Adjuvants are all the factors in the world which can stimulate our immune system. So, for instance, bacteria and viruses, they contain constitutively adjuvants. The adjuvants are also contained in vaccines. Those subjects who have already a very aggressive immune system, In some of them, the adjuvant may induce the Asia syndrome. Aluminum is one of those adjuvants. It's very cheap, very effective in stimulating the immune system, and therefore in most of the vaccine they use the aluminum as an adjuvant. And unfortunately, as you know, the vaccines are given to billions of people, and there is no personalization in this. And some of them who are genetically at risk might develop complications.
As we use more and more vaccines in a society, are we increasing our risk? Or is it going to be the same risk because it's always the same people, and whether it's 5 vaccines or 20, we're going to see the same autoimmune?
First of all, it's a good question, but nobody studied it. The FDA should have studied it. There are enough scientists in the world to do this study. It might be that increasing the number of the vaccine will not be associated with an increased number of autoimmunity. And at the same time, it might be. So let's analyze it, decide what to do, how to distribute them, but we have to do it in the proper way.
Well, so the FDA, CDC are saying we're doing all these studies, we've looked at it. Do you think that's an overstatement?
No. No, I don't think that it was done in the proper way. Most of the studies that were carried out on no side effect to the vaccine, if you will go to the end of the paper, scientific paper, you will see that the authors had a conflict of interest in this issue. And therefore, they should not be trusted completely. I mean, we are physicians. We owe the Hippocrates oath that we should do what is called in Latin primum non nocere, which means first, don't cause damage. So we have to make a better life for our subject, our patients, etc. The FDA should be more strict. They should be very careful in this case of the vaccine because of the debate that you are raising here, to have a better, or let's say more objective people to do the studies. We need the vaccine, but let's have a safe vaccines.
Amazing interview with Dr. Yehuda Schoenfeld. Just a little side note, I don't normally sit with one of the greatest scientists in the world with torn jeans, a pair of sneakers, and a sweaty shirt, except that, while he's putting on this gigantic conference, we had this window of time. We were supposed to be interviewing him at 2:30. He walks in at 1:30. Our lights are half set up, and he says, we do this now. And we're like, well, no, it's supposed to be an hour from now. And it was clear that this was the only time he had if we wanted him. So I just want to put that out there. But it also shows the great work that he's doing. You see these scientists coming in from all over the world, and then to take on top of this huge event, he's taking on this issue of vaccines and aluminum, which really, for someone of any of your stature, it's a risky step out. It puts in jeopardy all of the great work you've done throughout your life. But this conference, how important is a conference like this? How important is it to have a place where the brave soldiers like yourselves that are really going out and doing good science, it's not being supported by the pharmaceutical industry, it's rarely supported by government agencies. How important is it for you to come together with other minds like this?
One thing I always say is, and I learned this when I was out in Australia, there's a saying, I think it's musashi, it's a Japanese saying. It's more or less, I think, means, and someone will correct us later, know your enemy, which doesn't mean necessarily that anyone is your enemy. But if you're going to criticize someone, or if you're going to make a comment about someone, look them up first. Look up Yehuda Schoenfeld. Yehuda Schoenfeld is one of the most highly cited scientists in the world. So this means he has been through the regular process and come out the other end, and he has achieved big time. His achievements may or may not be recognized, perhaps because of what he has decided to do with his success. He's become a brave evangelist for autoimmunity. And that is a tremendous thing. But his background is hard, solid science.
He, in that interview, really seemed to lay out, when we talk about hard, solid science, that he doesn't believe that the the regulatory agencies, and the biggest really, you know, are CDC, FDA in America, really are driving a lot of where the World Health Organization goes. And he essentially says he thinks that, first of all, the manufacturers are doing most of the studies, not the FDA. And then there's no sort of rigors. And
No, he's.
what do you feel about that?
No,
Do you agree?
I mean, I heard the interview and he's absolutely right. I mean, we don't as scientists like to say that we can't trust some of our fellow scientists, but we are all also human. And not everyone, and Yehuda and myself, we argue a lot, but we have something in common, which we are both sort of on our own crusade of sorts, and nothing will deter us from that. And while, you know, I think Yehuda could easily have been corrupted, and I could easily have been corrupted, this hasn't happened. It does happen.
How does a scientist get corrupted? I mean, I
so
know we're going a little bit long here, but I have a rare moment to talk to you. But I mean, I look at, so I have to imagine most of you guys got into this because you cared, right?
Yes, you go into science for those reasons. But how do you sustain that scientific life? How do you remain in the faculty at the university? The universities put the pressures on you. They are, yes, they're interested in how good your science is, but they're much more interested in how much money you bring in. This is always the bottom line. If you want to become a full professor at a university, bring in $1 million a year, you'll be a full professor. You know, this is what it takes to achieve in the university, the academic system, not in science. You don't get recognized by giving, you know, by getting fellowships and things like that for achieving that, but you get through and up the system and you become important within the system. So those sorts of pressures are quite enormous in terms of, if you don't do that, and maybe you're not quite as good a scientist as you'd like to be, you might be on your way out. But if you can bring in some pharmaceutical cash on a regular basis, and, you know, I'm not going to be conflicted by that. Of course not. That's what you'll say. And to a certain extent, you almost believe yourself, but you are. And this is the problem. And you've mentioned it, Yehuda's mentioned it. What we need to do, what's happened now, is that our governments have decided to rely upon industry to fund safety science, pharmaceutical safety science. In other words, it's almost like trying to make money out of the safety issues. What we should be doing is, for example, in my country, the United Kingdom, all vaccine safety trials should be conducted by an independent organization, totally independent of industry, funded by industry, but totally independent of, so that
they have the billions of dollars, they can afford it, right?
Yes, of course they can. Now, would they concede to that? No, of course they won't. Because they manipulate trials, they change trials, they use the wrong controls, they use the wrong placebos, they publish some things, they don't publish others. Because they are not science, they are business. And those businesses, of course, do us all a great deal of good because they provide jobs, and jobs is, you know, your man in the US, Trump, he uses jobs as the main tool to get people on his side. And jobs are important everywhere. And that is what drives a lot of the time the decisions that are made, not science. Science is not driving these decisions. And sometimes I remember listening to you in your preamble earlier, it was as if science was to blame in some way. Yes, bad science is bad science, corrupt science is corrupt science, but pure science is just science. It's the people who are using it or not using it or not allowing it to take place. Now, these are people who are not actually in science. They're in business. Pharma are business. They're not science. They don't have to cure anybody.
So what is really happening? I mean, you know, we know many of the people in the movement say these scientists are brave. What's happening to your career? Are you at a high point now? You've released this paper, which, by the way, I understand this study of autistic brains has been downloaded how many times now?
About 250,000 times.
That sounds like a lot. Is that a lot?
In less than 6 months. Well, I've never ever experienced anything like it ever before, and I don't. And my peers out there, perhaps some of whom might be listening to this, might check their Mendeley statistics and probably find that the usual is like 20 times a month, not
Really?
not 50,000 times a month.
So I would guess getting that kind of attention, your university that you've been with through your entire career, right, would be
Yes,
jumping up and down. You're bringing all this attention to
most
Keele
of my
University.
career, yes. Unfortunately not. No, it's the opposite. It's the opposite with my university. And in many ways, I mean, going into those reasons is difficult, but let's just say we do have now in the last 3 years a pharmaceutical company on campus who use the university email system to sell vaccines to staff and students. And we have been working on vaccines for the last 4 or 5 years and elaborating on the ways in which some of the known serious adverse events may be due to aluminium in vaccines. So maybe my university needs the money from pharmaceutical industry to do better for the vast majority of students and staff. You know what? If they come to me and say, Chris, we do really appreciate you. You've been with us for 26 years. You've done some of the greatest science that this university has seen. But we're not going to use you as a flag bearer for the university simply because this area is just too controversial for us. If they said that to me, I'd accept it. They don't. Really, I feel that what their main interest now, simply because of our movement into vaccines, is for me to be removed from the university. This interview might be good enough for them to start that process off.
I hope not. I really do hope not. And it's one of the things that when I've been doing interviews with you guys, I even said to my team, if one of these scientists says something like, I'm not looking for a gotcha moment. I don't want to see you guys say something that steps out too far or sounds too much like a projection, because you have all been so careful throughout this week to really state the facts, as you have today. Say you're not jumping to conclusions. What you can prove, you have proved. But scientists are, I mean, there is such a few amount of scientists that are even bold enough to get into this. And every single one I talk to is on the verge of being removed from the university. I mean, the pressure is incredible.
Well, yeah.
What's it going? What can we do? What can we do as people out there watching? There'll be, tens of thousands of views of this right here. How can people that are waking up to this help?
Well, there are two approaches that will make a difference. The first is the only reason why we are doing some of the best research of my career at the moment is because of philanthropy, because we receive funding from the Children's Medical Safety Research Institute to do our work. Other than that, we would be doing nothing. I would be counting the rulers in the lab.
Because you're getting there's no pharma money coming in your way.
We get nothing from industry. We cannot get anything from the UK Research Council.
So no grants.
No grants from them. This is not because we don't try. We're never successful. We will get nothing from the charities because unfortunately the charities have so many conflicts, it's quite unbelievable. So we rely entirely on philanthropy, which means, but what that means is that if we get some funding through philanthropy, we can do some really significant science. We can do game-changing science. We are not expensive. For a fraction of the cost of, say, a clinical trial run by a pharmaceutical company, a 1/100th of it, we could do a game-changing study on Alzheimer's or on autism. Something which would absolutely tell us one way or other how much we need to be worried about aluminium in our everyday life. Now, that type of study could happen through philanthropy, through every individual who downloaded my paper, giving me $1 or so.
Right, there we go.
Just to read the paper. It would have been fantastic. But that type of approach, of course, the second approach is that everyone should ask questions. They should ask questions of their political representatives over and over again. Because as we found out, both you in the UK with the, you brought a man called Trump to the presidency. We've decided to leave Europe. People power matters. Whether you agree with the outcome
Whether you like
of
those
it,
outcomes or not,
exactly.
we've proven
Whether
that
you agree
people-
with the outcome, sometimes, and I think it's very, very rare, by the way, people power matters, and people can change this outlook, and they just have to be persistent. And they have to, and there are many of them out there, incredible evangelists, people with no scientific background who are trying to do this. And congratulations to them, thanks to them. But just by simply asking the question, yes, but this scientist has shown this is not safe, at least for everybody. Can't we just look into that? Can't we find monies to look into that? Can't we find independent studies to look into that, not performed by those, with clear conflicts and vested interests?
Chris, it's an honor to have you take the time to spend some time with us. I pray that you continue to be funded and others like you, and you continue to do the great work you're doing. So it's been a pleasure. Thank you very much.
Thank you for the opportunity to talk.